All right, this is guided practice, problem number 1 in Unit 8, Section 1. Use a table of values to graph y equals x squared plus 3. In class, when we did this problem, we discussed that Desmos is really great when you go from a table and you want to find the function. Here, we have the function and we want the table. So after we do this, we're going to state our domain and our range. So we're going to use the graphing calculator and new graph, enter our function up here. It's y equals x squared plus 3. Remember, y and f of x are the same. It's just different notation. X squared plus 3. Enter. There's our graph. We can get a lot of information from just looking at the graph. There's our vertex. It does not cross the x-axis, therefore we have no roots. But today I'm interested in finding a table. Go to Menu, Table. There you go. Now you have a table of values. It's always great to grab some on the negative side and on the positive side, and also be cognizant of where your vertex is. Grab some points to the left of that vertex and to the right of that vertex. So let's see if I can, I want to have, can I not do that? I was trying to minimize this, but I want it to go all the way away. All right, well, I guess I'll have to make it go all the way away. Let's draw a little table. Super old school here. X, Y. Let's do -2, -1, 0, 1, 2. So you guys in class asked me, where did you get those numbers? Those numbers are just numbers we are choosing. We can choose different numbers if we want. This is a pretty good variety, some negatives, some positives. Zero is always a great point to start with. And let's draw ourselves a little x and y axis. Grab a straight edge. Guess that's not so little. I made it pretty big. All right. Tick off. Tick off. This doesn't need to be super precise. This is just to give us an idea of what it looks like so we can figure out our domain and range. Let's pull our table back up. When x is -2, y was 7, -1, 4. You can't see this, but I'm writing it down on the little table I made in my book. 4 and 2 is 7. So I just jotted down these values. And our graph is going to look like that. So let's graph it. When x is -2, y is 7. -2, 7, -1, 4, 0, 3, 1, 4, and you guys noticing something? Is it symmetrical? It sure is. Doesn't have to be perfect, just gives us a general idea of what it looks like. There's our x-axis. Here's our y-axis. Now, state the domain and range. Think about it. When we think of our domain are what are our x values? Range are what are our y values? So domain. Are there any x values that you can think of that would not be included in this function? Is there something you could not plug in there? No, you can put any number you want. You can put positive 1,000,000, you can put negative 1,000,000. That would be a very large graph, but there's nothing you could not stick in there. So our domain is all real numbers. And I've been writing it like this. X is an element of the set of all real numbers. There's something called interval notation, which looks like this. X goes from negative infinity to positive infinity. But this is what I think we're going to focus on in Algebra 1 this year. Now our range. Our range is our set of our y values. So looking at our graph, I'll take my little unicorn Valentine here. I have not yet hit that graph. Bam! Right there. Whatever this y value is right here is where my graph is starting. And where's my graph going? Up. Up. My graph exists above this y point. So just ask yourself, 1, 2, 3, what is that y point? That's y is equal to 3. So our range is y is greater than or equal to positive 3. That's where it starts existing. There are arrows up here. So it is not stopping. It is increasing forever and ever and ever. Interval notation, you do the same thing, except this time you put a bracket because it's starting at 3. Then you'll put infinity. And that's open because it continues going forever. So when you have a quadratic, your domain is all real numbers. X is an element of the set of all real numbers. Our range starts at our vertex, the y coordinate of the vertex, and then you need to decide, is it increasing, going up? In this case it is. Or is it down? Is it going down? In that case we would use less than.